Good morning, guys. Welcome to section 6.1, day 2. I need you to kind of bear with me here at the beginning. Okay, I'm going to do something that may seem kind of silly, but you're just going to have to trust me that it's gonna help us with something we're about to do. Okay, so at the top of your notes, you're going to see this number line. So I've got a number line. It goes from 0 to 2. That's it, an itty bitty number line. And then underneath, and you'll see it's subdivided, so 0 to 2, this is 1, so this would be 1/2, and this would be 1.5, or I'm going to call it 3/2. There's a reason for that. Okay, and what I want to do is I want to take all of these fractions and I want to place them on the number line as closely as you can. Okay, so they're not going to be exact, but as good as we can. I want to put these fractions on this number line. Okay, so for example, I've got 3/4. So think about where 3/4 would go. There's a half, there's 1, so it's going to be right in the middle. Right? That's 3/4. Okay, that's it. How about 7/8? Where would 7/8 go? So think about the fact that 7/8 is a little bit less than 1. Okay, 8/8 would be exactly 1. So we are like 1/8 less than 1. So if this is a quarter, so we got 1/4, half, 3/4, this would be an 1/8, and that would be 7/8. Okay? How about 2/3? Where would you put 2/3? So if you're looking at one whole unit and we're chopping it into thirds, this would maybe be about 1/3. This would maybe be 2/3, and then a complete over to 1 would be 3/3. So maybe right about here. Again, this isn't going to be exact, but I'm trying to get as close as I can. What else we got? 7/6. Where would you put 7/6? Now, the important thing is you understand that 7/6 is bigger than 1. It's going to be over here somewhere, okay? Now, we can try to kind of pinpoint exactly where that is. Like, we were just talking about thirds. So if this is a third, then that would be like a 1/6. So 1, 2, 3, 4, 5, 6. So that'd be like 1/6, that little amount right there. So 7/6 would be 1 whole and then another 6. So maybe, I don't know, maybe here. 7/6. Okay, 9/8 should be right next to that. 9/8, again, is bigger than 1. Okay, this is like 1 and then 1/8. So maybe here. 9/8. 11/6. Ooh, 11/6. Well, where's that going to be? 11/6 is almost 2. 12/6 would be 2. So we're just shy. We're like that same 1/6 amount, but from 2 in this direction. So how about here? So 11/6. 1/3. Well, that's 2/3. That's 1/3. So 1/3 is less than half. So maybe here. 5/6. 5/6 is less than 1. All right, 6/6 would be 1. So we're just a little bit less than 1. We are 1/6 less than 1. A 1/6 should be between a 1/4 and an 1/8. Okay, a 1/6. So somewhere here. What was that? 5/6. And then last but not least, we had 15/8. So again, think about that. This is what I need you to understand. 16/8 is 2. That is exactly 2. So 15/8 is going to be a little bit less than 2. So maybe it's here. Okay? 15/8. Okay? That's all I need. I need you to understand those fractions and whether something is, a little bit less than 1, a little bit more than 1. Is it almost 2? Is it less than 2? If you can do that with a fraction, you're going to be just fine with what we're going to do today. Okay? Now, next thing I want you to do is I want you to think of, so notice I have 4 little sections here. So I'm going to take these 4 sections and I'm going to label them, and I don't want to confuse them with our other numbers, so I'm going to use Roman numerals here. I'm going to call this section 1. This is section 2, section 3, and section 4. Okay? Now, looking at these fractions, all I need you to be able to do is tell me which of those sections each of those fractions would be in. Okay, so 1/4. 1/4 is in which of those sections? Well, 1/4 is less than a half. It's going to be right here. That is in section 1. How about 11/12? 11/12 is almost 1. 12/12 would be 1. So it's going to be a little bit less. So it's going to be on this side of this line. So it's going to be in section 2. 4/3. Section 3. 4/3 is past 1. So that's going to be in section 3. 7/4. 7/4. All right. So 7/4 is less than 2. 8/4 would be 2. Is it a lot less than 2, or is it a little bit? It's just a little bit less than 2. It's like 1/4, because if you add 1/4 to this, you would get 8/4. That's your 2. So it's a quarter backwards from 2. So it's here in this 4th section. 3/8. Okay, 4/8 is a half. So that's right there. That's kind of that boundary line. So it's going to be a little bit less than that. So 1. 7/12. 7/12, a little bit more than a half. 6/12 would be a half. So it's going to be just on this side. Okay, so that's in that second section. And then 5/3. We may have to think about this one. 5/3 is bigger than 1. 5/3 is almost 2, because 6/3 would be 2. So 5/3 is going to be over here somewhere. So it's in that 4th section. Okay? If you're looking at what I just did and you're like, okay, this is really easy, why are we doing this? Then you're going to have no problem with what we're going to do today. Okay? So what we're doing is we're going to look at another way to measure angles. Okay? So what are we familiar with? We're familiar with degrees. So what is a degree? Well, they took a circle and they decided to chop it up into 360 pieces. So an entire circle is 360 degrees. Who chose 360? It was probably the Babylonians. They used base 60 for a lot of their number system. Why? It divides into fractions real easy. You can do a half, a third, an eighth, a fourth, a sixth, a tenth really easily without having to create decimals. Okay? So a complete circle is 360, that's 180, that's 90, that's 270, and we have all these little increments. But it's a very, very small measuring tool, and once they agreed upon it, we just all use it. So it is a standard unit of measure that we all agree upon and we can use freely, and I can use it here. Someone in England can be using the exact same unit of measurement. It's consistent. Well, you could create whatever you wanted. You could say, let's take a circle and let's chop it into 100 pieces, okay? And you could name it whatever you want to name it. Name it after yourself. Be famous, okay? And then you'd say, okay, so a complete circle is 100, so this would be 50 francs, whatever they are. Okay, this would be 25 francs. This is 75 francs, and you could cut those up, and that would be your unit of measure. Now, I don't think anyone else is going to go along with you, but you could do that, okay? So what we're going to talk about today is something called a radian. And a radian is just a different unit of measurement. Okay, so get that kind of sunk in first. So here's what they did. They said instead of taking this and chopping it up into a certain number of pieces, let's use a consistent measuring tool to determine kind of our standard unit. So what they said was, okay, let's take a circle and let's take the radius. Now, if you look over here, you're going to see this. They're going to take the radius and they're going to lay it down and curve it. And they're going to say, okay, this little piece of the pie that we just cut, using the radius of a circle as our unit of measurement, we are going to call that 1 radian. That is a radian. Okay, So instead of being a degree, which is a very, very tiny sliver of our circle, we have this bigger unit, and it's called a radian. And that's it. Okay, that's what it is. Now, here's what you find. Because you're using the radius as a unit of measurement, you could go around, so that's 1 radian, go around maybe about here, that'd be a 2nd radian. Then you could go around to about here, that would be 3 radians, so this is 2 radians, this is 3 radians. Now, 3 radians is not quite all the way across. Okay, we're almost to the opposite side of the circle, but we're off by a little bitty amount. So, what number that is bigger than 3 that you hear a lot in math classes do you think is represented right there? Okay, if that's 3, that is 3.14159. This is pi. Okay? Because we're using a radius, and because the circumference, which is what we're doing, we're going around the circle, the circumference of a circle is 2 pi times the radius, then that means a complete circle is going to consist of 2 pi of these radians. So that's 1 radian, that's 2 radian, that's 3 radian, that's pi radians, and that's 2 pi radians. Now, once you understand that, we're never, ever going to talk about 1 radian or 2 radian. We're going to use increments of pi to talk about these things. Okay? So looking at a circle, this would be 0. Halfway around is 1 pi radian. And we usually just list that with a pi symbol, but I'm going to put the 1 there just to be more specific. That is 1 pi. This up here, so then a complete circle would be 2 pi. So this would also be the same as 2 pi. Halfway, that's half pi, right? So if this is 1 pi, that's halfway. So that's 1/2 pi, or pi over 2. Half pi. Take a pi divided by 2. That's half. And then down here, this would be 3/2, or 3 pi over 2. So when you're dealing with radians, everything is going to be written as fractions, but we're going to use these, like your y-axis, your negative x-axis, your negative y-axis. We're going to use these borders, and we're going to use these common fractions that we're going to see over and over and over, and then we're going to use those to determine where exactly the radians I give you are going to be. Okay, so these are the ones you've got to learn. So this is 1/2, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so for example, if I wanted to draw 5 pi over 6, here's what I need from you. I need you to draw the initial side, and then I need you to say to yourself, okay, 5/6 is a little bit less than 1. That was the game we played up top. 5/6 is less than 1. And this is 1 pi, halfway around the circle. So I should be a little bit less than that. So for today, that's all I need. I need you to draw an angle that's a little bit less than 1. We're going to say that's 5/6, and that's our angle. That's it. That's what we're doing. So everything is a fraction, and you're thinking in terms of, is the fraction that he gave me, is it a little bit more than 1, a little bit less than 1, is it almost 2, is it a little bit less than 1/2? So look at the next one. So draw your initial side. 9 pi over 8. 9/8 is a little bit less, is a little bit more than 1 by an 1/8. Now I don't know exactly what an 1/8 of a radian looks like. I'm not worried about it. All I know is I'm going to draw an angle that is a little bit past 1, and that's my angle. That's it. Okay? See what you can do with the next two. See if you can think where the next two are going to be, and then I'll draw them and I'll replay this. So hopefully this is what you came up with. 11/6 is almost a complete circle. 12/6 would be 2. So you're almost all the way around, not quite. So that's the angle that we're talking about, 11 pi over 6. Next one, if this is a 1/2 pi, a 1/4 pi would be right, it's like a 45-degree angle. Okay, so pi over 4 is exactly equal to a 45-degree angle, which we're going to talk about a little bit later. Okay. All right, so on the back, we're going to talk about something that we talked about in the previous lesson. We're going to talk about coterminal angles. So we did this with degrees first because you're familiar with degrees and it would make more sense to you. So now we're going to connect that idea to radians. So remember, a coterminal angle means you have some angle, and if you add 360 degrees, staying with degrees for a second, 360, you're going to land right back where the other angle is, so those two angles have the same terminal side, and they are coterminal angles. So we're going to do the exact same thing, except a circle for us, one complete revolution, is going to be 2 pi. So instead of adding 360, we're going to add 2 pi. Now, at the beginning, this is going to be kind of weird, but once you get into the habit and you kind of see what's going on, okay, with radians, we do work with fractions a lot. And I know you're not big fans of fractions, okay? But the fractions are always small, and they're always going to be something that's easy to use and something where we can easily find like common denominators, and we're not going to have to grab our calculators. Okay, when you're dealing with degrees, because the numbers are so big, you're subtracting 360, subtracting 360. Okay, you need your calculator a lot. We're not going to need that. Okay, so let me show you. So first thing we're going to do is we're going to identify all angles that are coterminal to the given angle. So we are going to take 2 pi over 3, and we are going to add 2 pi k. Okay, so just like we did the other day. So these are multiples of one complete circle. Okay, any multiple, you're going to land on a coterminal angle. And then we're going to find one positive and one negative coterminal angle of this angle. So we're going to do what we did yesterday. We're going to take, so to find a positive, we're going to take the given angle, and we are going to add 1 revolution. Now, this is where you got to stop and think. To add fractions, I need common denominators. Well, if this fraction has a denominator of 3, and 2 pi has a denominator of 1, okay, it has a denominator of 1, then that would be my common denominator, would be the 3. So think of how you would write a fraction that is equal to 2 that has a denominator of 3. Well, here's the trick. You just need the numerator to be twice as big as your denominator. Okay? 6 pi over 3 is going to be the exact same as 2 pi. Okay? They're going to be equal to each other. 6/3 is 2. If I had a denominator of 5, it would be 10/5. If I had the denominator of 7, it'd be 14/7. All you do is take your numerator, or take your denominator, double it, and then that's your numerator, and that fraction is going to be equivalent to 2 pi. So now I can add these two things together. Don't need a calculator. I am literally just adding 2 plus 6. That's it, because we're just combining like terms. You're adding across the numerator 2, so think of it, 2/3 plus 6/3 is 8/3. So 8 pi over 3. That's our positive angle. If you want one negative angle, we're going to do 2 pi over 3, and we're going to subtract 6 pi over 3. Okay, so again, all we're really doing is taking 2 minus 6, which is negative 4. And then we're going to write it using the fraction and using the pi, so it's going to be negative 4 pi over 3. Okay, that's it. So 5 pi over 4, that's the given angle. So the first thing I'm going to do is I'm going to write all the coterminal angles, which would be 5 pi over 4 plus 2 pi k. Now, I'm going to think, this is my thought bubble, of 2 pi as a fraction that has a common denominator of 4, because here in a second I'm going to add and subtract that value to the 5/4 to get one specific positive coterminal angle, and I'm going to find a negative coterminal angle. So I'm thinking of the number 2 as 8/4. 8 pi over 4 is equal to 2 pi. So that's 2 pi written as a common fraction, and now I'm good to go. My positive angle is literally 5 plus 8. Okay, you add the numerator, you keep the same common denominator, and you tack a pi onto it. So 5 and 8 is 13. So 13 pi over 4. That's how you do it. I know this is weird right now. It looks weird to you, but it's just adding two fractions together that are kind of small fractions. How about a negative? All right. Well, that'd be 5 pi over 4 minus 8 pi over 4. So 5 minus 8 is negative 3. So that's our answer. Negative 3 pi over 4. Now, just like yesterday, when this is going to be most useful is if I give you an angle that's like way, way, way too big, and we want to kind of unwind those revolutions so we can actually kind of see what the angle looks like. Or if I give you a negative angle, and you're like, okay, I can't picture this negative angle, I want a positive angle. So what we're going to do is we're going to rewrite both of these as angles that are between 0 and 2 pi, so 1 revolution. That's what that is. That is a fancy way of saying 1 positive revolution. That's where we want our answer to be. Okay, so 16 thirds is way too big. Okay, 16 divided by 3 is like 5 1/3. Okay, so they've gone way too many times around. We need a number that is less than 2. Okay, it's got to be between 0 and 2. All right, so let's just subtract revolutions until we get there, until we get a fraction that is smaller than 2. So first I'm going to subtract, so we're going to subtract 2 pi, but I'm not going to write it as 2 pi. Okay, I need a common denominator. So what is that? Think, 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 think. All right, 6 over 3, right? 6 thirds is equal to 2. So that's how we're thinking of 2 pi, so that we can subtract it with our common denominator. So 16 minus 6 is 10, so 10 pi over 3. Well, that's still too big. Okay, I need my answer to be less than this 2 pi that we're using. Okay, I need an answer between 0 and 2 pi. So do it again. Subtract another 6 pi over 3. All right, so what's that? 10 minus 6 is 4. 4 pi over 3. And that is smaller than 2. 4 pi over 3 is bigger than 1. That's okay. It just means it's an angle in quadrant 3. Okay, but this is our coterminal angle that we can actually deal with, and we can kind of visualize, and we could graph it if we needed to. Like I said, it'd be like 1/3 past 1. Okay, so it'd go into quadrant 3 a little bit. Okay, the next one's negative. That's a negative angle. Don't want a negative angle. I need numbers that are between 0 and 2 pi, so it's going to be positive. So we're going to add 1 revolution. So what am I going to write? Okay, I need to rewrite the number 2 pi, but in a way that has a common denominator. And I'm sorry if I'm being repetitive, okay, but this is important, and you got to get really good at this. Okay, so just real quick, you're going to look over here, and you're going to say, oh, 8/4 would be my magic fraction that's equal to 2, but has a common denominator, so 8 pi over 4. Okay, I usually think of it just as a fraction, and then I attach the pi symbol. Okay, so that's what my brain is doing. I'm going, oh, 3/4, 8/4. That's the number I want. And then I go, oh, yeah, it's got to be 8 pi over 4. All right, so negative 3 plus 8 is 5 pi over 4. We're done. That's it. That's all you do. Okay, again, this one would be in quadrant 3 because it's a little bit less, or it's a little bit past 1. So 1 pi, that's that boundary between the second and third quadrant. Okay, same with this one. 5 pi over 4 is bigger than 1 by a quarter. So it would be 1/4 of the way into that quadrant. Okay, so that's also quadrant 3. Okay, last thing we're going to do is I'm just going to show you how to convert. Okay, so if you're given degrees and you need radians, or you're given radians and you need degrees, all you have to do is convert. Now, so I'm going to show you how to do something. It's kind of like what you did if you've taken a chemistry class, where it's called like stoichiometry. I think that's the fancy chemistry name for converting. So what we do is we need a common connection between the two things. Well, we know that 1 revolution, which is 360 degrees, is equal to 2 pi radians. But using 360 and 2 pi isn't the easiest way to do it. This is a very easy connection. 1 pi, so we don't have a number out front, just 1 pi is equal to 180 degrees. And so that's the unit, the conversion unit we're going to use. That 1 pi is equal to 180, and a 180 is equal to 1 pi. So what I have here is I have these two little fractions. I have pi over 180, and I have 180 over pi. So if you're wanting to convert, the trick is make sure things cancel. So if I have 80 degrees, so 80 degrees, and I'm wanting to turn that into, so I'm wanting to turn this into radians. I have degrees. The degrees are in the numerator, so I need to put some degrees in the denominator so they'll cancel. So the fraction I'm going to use, I'm not even looking at these. I just know I need the 180 to be down here. I need these two degree symbols to cancel with each other. Something in the numerator, something in the denominator. It's like when you convert like feet per second, and if you've got feet up here, you got to make sure you got feet down here, and you're trying to turn it into meters or something. Okay, so 180 goes here. That means the pi symbol goes here, and then my whole job is just to reduce this. Figure out how to reduce. Well, I'll tell you what, those two zeros are going to cancel. Okay, I can divide everything by 10, and now I have 8/18, which those are both even numbers. So I would divide it by 2 and get 4/9, and then that's it. There's no more reducing. So 80 degrees is equal to 4 pi, we still have our pi symbol, over 9. That's it. Okay, 140. 140. We're going to multiply it by, well, this is degrees, so I'm going to put the 180 degrees on the bottom, put the pi symbol on top, and then your job is to figure out how 140 and 180 reduce. Again, the zeros, 14 over 18 would be 7/9. That will not reduce anymore. Easy peasy. Okay, so 140 degrees is equal to 7 pi over 9. Negative 30. Now, if I give you a negative, I'm not wanting you to like turn it into a positive. I just want to convert it. A negative degree should convert into a negative radian. So, negative 30, 180, put the pi up there. The zeros will cancel. 3 goes in. So, again, negative. If this is a negative, this is not a negative, so they're not going to cancel. My final answer is going to be a negative. 3 and 18, that reduces to 1/6. So, pi over 6. That's it. Okay? The other direction. Well, we're going to do the other thing. 5 pi over 6. We're going to turn it into degrees, which means I don't want that pi symbol anymore. So, put the pi down here. Put the 180 up here. And then multiply, reduce. Let the pi's cancel. You could do in your calculator 5 times 180 and then divide it by 6. You could also reduce right now. 6, like cross reduce. 6 goes into 18 3 times, so it's going to go into 180 30 times. So now everything's canceled except the 5 and the 30 that are multiplying, so that is 150 degrees. That's it. Okay? Negative 3 pi over 5. I want my pi to disappear, so I need to put a pi symbol down here. These are now going to cross reduce, cross cancel. Okay? I'm also going to have 180 there. That's the fraction that's going to convert this for me. Okay? So again, that. You may not quickly see how many times 5 goes into 180, so maybe this is a time where you do. You grab your calculator. Okay? I'll grab my calculator. It's going to be negative. And then I'm just doing 3 times 180 divided by 5. You can do all that in one step. 108. Okay. Negative 108. That's it. Okay. Go ahead and try that last one. See if you can figure that one out. I'm going to pause this. All right. And you should have got 135 degrees when you did that. Now, down on the bottom, you're going to see some common conversions between degrees and radians. These are things that we're going to use a lot. Okay, so like knowing that pi over 2 is equal to 90. Okay, those are two things you're familiar with, which means half of that, which would be pi over 4, is equal to 45. These are things that you're just going to kind of learn as time goes by. This is 1/4, this is 1/2, this is 3/4. This is 1 pi, so this is 5/4, and 6/4, which is 3 over 2, and 7/4. So these are fractions that you're going to become familiar with and comfortable with as we go on. But for now, that's all we're looking at. Okay, so take a look at your homework. Let me know if you have any questions. Thanks.